Right, question number 7 of KZN September 2017. That is equilibrium question. So question number 10, question number 7, they say 10 grams. So here's 10 grams of hydrogen gas and 355 grams of chlorine gas. So that is Cl2, and then hydrogen gas is H2, are heated together in a sealed 500 centimeter cube. So we convert a centimeter cube to decimeter cube. So if we divide this by 1000, so we'll have 0.5 decimeter cube contain. So equilibrium is reached at 450 degrees Celsius. So take care of the temperature. So because about to change, it will affect, of course, the equilibrium. Right. They're saying the reaction is balanced below. Now we need to consider this. That is the forward direction by looking at this forward direction, meaning this forward direction is exothermic, and then the reverse direction or the endothermic direction. So always this represent a forward direction. This will represent a forward reaction. So the reverse will be represented by the reverse arrow here. Right, the equilibrium constant for this reaction at 450 degrees Celsius is 60. Now we have our Kc of 60. Right, calculate the mass of the chlorine gas present at equilibrium. So the mass of the chlorine gas present at the equilibrium. So our table here is given. Normally we draw a table with the number of moles, but here we're given the masses, which is the grams. So we're going to convert this grams to mass. So we use our periodic table. So for H2 gas, the number of moles of H2 equals to the mass over the molar mass. So what is the mass? We're saying 10 grams over what is the molar mass of hydrogen. Of course, it will be hydrogen times 2. So hydrogen times 2. So that will be 2 of the mass of hydrogen is 2, and that is 1. So we say 2 by 1 because there are 2 hydrogens according to this one. So this will be 5 moles. So we have 5 moles there. So for Cl2, chlorine gas, so we have the number of moles of Cl2 equals to the mass over the molar mass of Cl2. So we're going to have, let's say we have 355 over, so chlorine is saving a mass. Let's check the periodic table. Cl here saving a mass of 35.5. So, but we have 2 of them. So we're going to have 2 into 35.5. Right. So what do we have? So let's try to pick up our calculator. So we're going to have 335 divided by 2 times 35.5. If you check that, so what's happening here? So let's try to do this, and then close the bracket. So right, we're having 4,71. I don't know what's happening with the calculator. So, but we have 4,71. So that is our calculator saying. It is 4,72 in fact. So let's write it. 4,72 moles. So this is what is recorded. Right, now we can have our table. Let's draw our table down there. So we know that our table is having the reaction. Now from the reaction, we are having, let's do this, our reaction is H2 and then plus Cl2, then the reaction reversible 2HCl. Then we have the initial moles, and then okay, the initial moles, this one is 5, so let's do like this, and this will be the last part. So the initial, we have 5, 4,7, 2. Now initially there is no product, always is 0. Right, from there we have the reactant, reacted. The reacted number of moles. So initially we have unknown, reacted, and then we use, or they must have given us something at reacted, but of course let's start by equilibrium. Let's not start by reacted, we start by, so this will be the reacted, it's fine. So from the reacted we have the equilibrium. From the equilibrium we'll have the concentration equilibrium. Let's see. But in our the equilibrium constant for this reaction, okay, is now 60. So they must say something at equilibrium. So the only 20 grams of chlorine gas are heated in a sealed container. So equilibrium is reached at this time. So the equilibrium constant for this one, reaction at 450 is 60. So calculate the mass of the chlorine gas present at equilibrium. So they want the mass of the gas present at equilibrium. So they said nothing about one of the contents at equilibrium. So if they said nothing, so roaring Mortimer reacted. We use the ratios here. So the ratio of this one is unknown. So we have x but this was used, so we have minus x. Because CL truly number was used, we have minus x. That is 1. The ratio is 1, 1. So now moving with this one to the last one, the ratio will be now 2, but this the product will be plus 2x that is produced. So when I produce, there is show a change of a positive. After that, we add initial plus this minus change. So what I will say 5 plus minus x. So the at equilibrium, it means we have 5 minus x. Even here we have 5 minus x. And then this plus this will have 2x. Now we're given a volume of 0, 0.5. So we're going to divide each by 0, 0.5. So saying 5 minus x over 0, 0.5, 5 minus x divided by 0, 0.5. Remember the concentration is C equals to N over V. So the volume is there, the number of moles of at equilibrium is given as 5 minus x. So this will be 2x divided by 0, 0.5. Right from here, we have our concentrations at equilibrium. So we can take this further. Then now we can have our Kc value. Now our Kc here is the gases. So will be the product, which is HCl squared over the hydrogen gas multiplied by the Cl2 gas. So it's to the power 1 to the power 1 because the coefficient or the ratios is 1. Now, I mean, having the Kc like this, then we'll get the mark for that. Of course, now we're going to have Kc being 60 equals to, then this will be, what was the product? This will be 2x over 0, 0.5 all squared. So we can use a curly brackets because now we're substituting here. And then we have 0, is it 5 minus x over 0, 0.5 multiplied by 5 minus x over 0, 0.5. Right, when multiply this are common, so let's take it right there. So we're going to have 60 equals to 2x over 0, 0.5, and then of course all squared over what we have, something's missing. So in fact here you must have 4,72, not 5. Even here one of them is 0,72, something like that. I think there is a problem with this question, but it's fine. So we can take out we're supposed to take out the square root, the squared for this one and the other one. So let's go back to the calculator and check something. So there's 0, 355 divided by 2 times 35,5. Yeah, we did a mistake here. That is supposed to be 5. Is fine. That was supposed to be 5. So let's erase this. So it's fine here. It's fine as 5. It means here it's also 5. 5 minus, we missed with the calculator. So that should also be 5. Now if it's 5 minus x, now we're going to have 5 minus x over 0, 0,5. Because we are multiplying common things, we're going to have squared. Then now we can square root each part here. So if we do it like this, square root of 60, square root of this one, square root of this one. So let's take the calculator. Square root of 60, square root of 60 is 2 root of 15. It's fine. It means we can have, let's take it to the top. It means we can have square root of 60 equals to, now we're going to have 2x over 0, 0,5 divided by, now we have 5 minus x over 0, 0,5. So now, because this is this division, so we can take the whole of this, come and multiply here. So we can have square root of 60 multiplied by 5 minus x over 0, 0,5 equals to 2x over 0, 0,5. Then we can multiply throughout by 0, 0,5, so the 0, 0,5 will disappear. Let's erase the table now. So we have a problem with the system now. It's running low poor. Right, now if we multiply throughout by 0, 0,5 here, it's going to move out. So now it means we'll have square root of 60 into 5 minus x equals to 2x. Then what can we do here? Of course, we can divide throughout by 60 so that we have 5 minus x equals to 2 over square root of 60x. Then we can take x to the side, we have 5 equals to 2 over square root of 60x plus x. Now we're going to add these ones. So we're going to have 5 equals to x into 2 over square root of 60 plus 1 if you take out this as a common factor. Or we can just add them as like terms. So we're going to have this one, 2 divided by square root of 60 plus 1. So we're going to have 1, comma 28. So we'll have x equals to, now we're going to take 5 divided by the answer. So now we'll have 5 divided by answer, and then it means now we're going to have our number of moles of x at equilibrium as 3, 3,97 moles. So this is not yet the answer, but this is the number of moles of the chlorine gas. So let's see the ones that are present at equilibrium. So we removed our table, but for the chlorine gas we had something like this. So to get the number of moles at equilibrium, so we're going to take this. So let's squeeze it here. Let's write it here. Now it means we're going to have, for us to get the mass, we can get the number of moles at equilibrium. So what is it? At equilibrium we'll have 5 minus 3,97. So that is the number of moles at equilibrium. So let's press the calculator. So we have 5 minus the answer, in fact we have 1,03 moles. Now this is the number of moles at equilibrium of the chlorine gas, but the question is looking for the mass. So you go further with the formula of the mass. So the mass equals to N multiplied by the molar mass. So we're going to have 1,03 mole multiplied by what will be the mass of the chlorine gas. The molar mass is 2 by 35,5. So what do you get? So the calculator. So this answer multiplied by 2 by 35,5. So here we have our answer is 72, 85 grams. Now that would be the final answer that they were looking for. Right, that was a long question. Right, let's answer these short ones quickly. They say the temperature is now increased. Now let's go back to our blue car. The temperature is now increased, take note of this, to 550 degrees Celsius, while the volume is kept constant. The system reaches a new equilibrium. Yes, state the Litourge's principle. Now it's just stating the Litourge's principle. Symbol says when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose the disturbance. So after stating this, I think we need to apply it down there. How will the following be affected in the new equilibrium? How will be the following be in the new equilibrium? Right? Only increase or decrease or remain same. the equilibrium constant here. So how do you see? So by increasing the temperature, we're going to favor the reverse reaction, which is endothermic. Then if the reverse is favored, then on the products here, the products are going to decrease. So as the product decrease, it means the reactions decrease. So we're dividing by a bigger number here. So it means the answer will be decrease here. The volume of H2 present. Now, the volume of H2 present now, because we're favoring a reverse reaction, now this content will increase, because if we favor this one, we're going to add a lot of things on the reactant. So the volume of the reactant, of course, supposed to be increase. Use the Lechele's principle to explain the answer in question 7.3.2. Right? From the Lechele's principle, we're going to say the temperature was increased, of course. Then according to the Lechele's principle, increase in temperature favors endothermic reaction. Increase in temperature favors endothermic reaction. Endothermic reaction. Now we get a tick for that. Therefore, because only 2 marks after favoring the reverse increase the endothermic reaction. Which reaction is, we must mention which is favored. Therefore, reverse reaction is favored. Then if the reverse reaction is favored, then that's why we have an increase in the H2 present and also the Cl2 present. Now that's it for the chemical equilibrium. So you can repeat the video if you did not understand. So if you repeat again, you may get something.